All right. Hello, everyone. Morning, afternoon, evening, depending on where you are. Thank you for joining today's Data Science Festival event. I am Leila Seith Hassan, and I am going to be your moderator and host for today. So a relatively quick upfront from me before handing over to Divya, who you will come to hear and see. This month, Data Science Festival is hosting a Women in Data Month. So normally DSF doesn't actually run gender-specific events, and that's primarily because they believe in a diverse range of speakers, and attendees should just fundamentally be the norm. But over about the last 5 years, they've realized that the events have averaged out at about 40% female speakers and attendees. And so in 2021, they really want to bring that into equal balance. And also, we're just generally aware that, there's a bit of a lack of female representation, particularly in our sector. And so this month, they really want to celebrate the incredible women that are shaping the Data Science Festival, data science world. And so we ask that those of you that are here today, please share out on social media so that we can get a larger audience and kind of larger following and more people aware. And also there are other events coming up in the month, so it would be great to have attendees on for that. So a little bit about me. I head up the data science and analytics practice at Digitas. We are the Connected Experience Agency, and we've had a partnership with Data Science Festival for over a year now. My department really uses data to enable, understand, predict, optimize customer experiences. And we do that with lots of different data and lots of different techniques. Though we consider ourselves tool and language agnostic, we do work with lots of different clients on lots of different problems. And I think one thing that's quite key, we really care about building diverse teams that are filled with lots of different people from lots of different backgrounds with lots of different ideas and skills. And so if that sounds interesting to you, and it's also something that you care about, we have openings at the moment and we're hiring. So we'll be dropping in an email in the chat today, and feel free to reach out and add Data Science Festival and Digitas in the subject line if you want to know more. For now, though, it is my absolute pleasure to introduce Divya Rana. She is a data scientist at Digitas, and she is today's presenter. Her passion for data science and to make data science better for everyone, those that do it and those that feel the effects of it, are just part of what makes her so great. She's also incredibly creative with her applications of data science, which you're going to see today. And she's always looking for better ways to solve our clients' problems in ways that are good for them, but also good for our consumers. And I also think she's just lovely and a fun person to work with. She's got a passion for the NBA, which you're likely to see in today's presentation. And I just generally think she makes our department better for having her in it. She's going to talk about gender bias in classification models today. For those of you that haven't already, please say hi in the chat. This is also where you can ask questions, which we'll get to at the end of the presentation. But to now, over to Divya, and I'll ask her to unmute, put on her camera and share her screen when she's ready.
Perfect. Thanks very much, Leila, for that introduction. And let me share my screen. Cool. So today I'm going to be talking about gender bias in zero-shot text classification. So firstly, a little bit about why I chose this topic. So as you probably know, large volumes of data are required to train all transformer-based models. And so getting such large data sets, which are completely free from biases, is quite a difficult task, meaning that bias becomes a widespread problem in natural language processing. And it's certainly not unique to ZeroShot. However, zero-shot text classification models have become popular for their usefulness in classifying text without any need for further training. And while this can be incredibly useful in many instances, hopefully with this talk, I can show you why we must still examine and think about the model we're using and not just take it out of box, as you say. So what is ZeroShot? ZeroShot text classification allows you to classify text with any topics, emotions, or situations without the need for having the model being trained specifically for those classes. And one way to achieve this is through natural language inference training. So we can take any base transformer model, be that BERT or BART or Roberta, and then add to that a classification head for natural language inference. So for example, let's say we had the premise text, the dog barked at the owner, and we had the hypotheses that the dog was making noise. Now this would be an entailment because the hypothesis is true. Let's then say we had the premise, the shops were closing, so we had to run. And the hypothesis would be they were walking slowly. And this hypothesis is not true, so it would be labeled as a contradiction. And finally, if we had the premise, the train arrived at the stop and we had the hypotheses that they were late, this would be neutral because we don't know whether they're late or not. So this classifier therefore learns the relationship between a premise and a hypothesis and decides between three classification labels: entailment, which is true, contradiction, and neutral. And so based on its understanding of language, which it's learned from BERT or Roberta or BART, and then its added understanding of entailments, i.e. how does the premise relate to the hypotheses, it can therefore extrapolate this to any text and hypothesis pair without specifically having been trained for that pair. So when should we use it? This approach is especially useful in the case when you don't want to limit the number of classes. So let's say, for example, you wanted to monitor news topics in the news. Now, you don't know what's going to be in the news from one day to the next. So you don't want to limit yourself by having a fixed set of classes. You'd probably want to have, a rolling set of classes that's continually changing, in which case ZeroShot is incredibly useful. Also, if you don't have labeled training data, or you don't have good quality training data, or you don't have enough training data, ZeroShot can be really useful in that sense. And if you're dealing with a specialized case, so for instance, you don't want to classify just general news, you want to classify specific news related to travel, you can also fine-tune the entailment-based head to be specific to that topic. So just a disclaimer though, in the case of a fixed number of classes, so let's say for your use case, you only wanted to decide between 3 or 4 topics, or you had training data with a fixed number of classes, a traditional text topic labeled train classifier will always be more accurate. So now, what is bias? Well, in this talk, we'll be referring to bias in the spoken word sense, specifically gender bias in this talk. And it often manifests completely unintentionally. It can manifest through imbalanced data sets, and that's called sample bias. So for example, if we take text from English language speaking sources, they're likely to be, Western centric, and minorities are likely to be, underrepresented in these data sets. It can also manifest through leaving out important variables. So let's say you wanted to do a study on the factors which affect education level, and you left out, postcode. That would be an example of exclusion bias. It can also come from poor experimental design, where the experimenter's own biases might result in biased practices in the experiment. And finally, learned bias, which is quite a big problem in NLP, where the data, so for instance, the text could have, biases within them. So if your text had racist language or homophobic language, your model will just learn this. So in the case of ZeroShot, where might this come in? Well, it could come in when you're training your base transformer model, so your BART or BERT or Roberta. It could also come in when you're training the NLI classifier head, or it could come in any further fine-tuning that you apply, or even in the text to be classified itself, which unfortunately we don't have much control over. So for example, BERT is trained mostly on Wikipedia articles, which have learned bias. So any bias language within a Wikipedia article will be learned. And as you know, anyone can write a Wikipedia article. So there's likely to be, racist language, heteronormative language, homophobic language, gender biased language, all of that will be learned by BERT. There's also sample bias. So the collective of English language Wikipedia articles is likely to be Western centric, and minorities, just by definition, will be underrepresented. And so as a result, BERT's understanding of language is highly male-centric, Western-centric, heteronormative, neurotypical, etc. Then we'll go on to training our classifier heads. So the most common dataset used by the ZeroShot models on Hugging Face is a subset or the actual Stanford NLI dataset. So let's look a little bit about how this dataset was curated. In 2014 and 2015, 30 paid workers were presented with a caption and asked to produce 3 alternate captions. One that is definitely true, an entailment, one that might be true, so neutral, and one that is definitely false, that would be a contradiction. So just thinking about this, we can already see some problems, right? There's 30 paid workers, only 30 people's views and stereotypes will be concentrated into this large data set. And this data set was collected in 2014, 2015. So the views they held at the time are likely to be outdated as time goes on. And even on the dataset card for the Stanford NLI dataset on Hugging Face, they say that, the crowd workers provided examples which reproduced harmful stereotypes or pejorative language in the hypotheses. So if you go on the Stanford website, which shows this dataset, even just looking at the examples they provide on the webpage, you can see some gender bias. So, a soccer game with multiple males playing, a smiling costumed woman holding an umbrella. So these are immediate stereotypes that you can see just from going onto the website. And then finally, when we want to fine-tune the head, for instance, to make it sports specific, the data that you fine-tune with might have stereotypes in it. So let's say you wanted sports specific topics, you might scrape news data for this and use the scraped terms as the topics. Or just going on Google and looking at sports news, most of the news is about male-centered sports. So already we have an imbalanced data set, but also there's often, gender biased language in these articles or tweets and things like that. So you could have learned bias from that as well. And so depending on the source, will be centered or skewed to a specific country. So most English language data is sourced Western skewed. And then finally, the text itself, which you want to classify, may have a bias as well. So let's just look at some examples of bias when using a ZeroShot model. Let's say we had the topics, man and woman, and we wanted to look at the similarity with the word weak. So we have a 69% similarity between weak and woman, but only a 30% similarity between weak and man. Similarly, boss has a 53% similarity with man and only a 46% similarity with woman. And then, biases can work both ways. So intelligent has a 60% similarity with woman and only a 39% similarity with man. So the point is that these differences shouldn't exist, and they're a result of learned bias. Also looking at LGBTQ bias, which is not the focus of this talk, but there's still bias on that axis. The words immoral and dirty are more likely to be associated with the LGBTQ plus community, whilst the word pure is much more associated with heterosexual, straight woman, straight man. Obviously, this wasn't the intention of the people who trained the original model, but it's a result that we have to look out for. We can't use these models in client-facing work or public-facing work because we're exaggerating harmful stereotypes. So let's think about the case study that we are monitoring upcoming topics in the sports news. Now here, as we've seen, we'd probably like to use ZeroShot because we don't want to limit ourselves to a fixed set of topics. And given that sports news is a fairly narrow topic, we might want to fine-tune our ZeroShot head further by feeding it sports-related sentences structured as an NLI dataset. Now we can take any labeled dataset and turn it into an NLI dataset as follows. So let's say we have the text, players will be tested twice a week to reduce transmission, and the topic would be coronavirus. We can turn this into an entailment by forming the hypotheses this text is about coronavirus. Similarly, we can choose any incorrect topic at random to form a contradiction. So for instance, this text is about skiing holidays. So now that we've seen gender biases exist within the model, let's have a look at how gender biases can lead to incorrect classifications, so bias in the machine learning sense. So if we just look at the gender bias to start and have the candidate labels, man is playing sport and woman is playing sport. And if we take the text, the football player trained all day for the finals, we see an 84% relationship with man is playing sport and only a 15% relationship with woman is playing sport. Now, if all we change is the word footballer and change it to dancer, these probabilities are flipped. So we have a 93% relationship with woman is playing sport and only a 7% relationship with man is playing sport. So this is the gender bias. Now, how can it lead to incorrect classifications? So if we take the candidate labels footballer and dancer, and we want to figure out if the text is related to a footballer or a dancer, let's say those are our topics. If we have the text, he trained all day for the finals, we'll classify this text to be about a footballer. But if we change this text only by the gender pronoun, so if we now have the text, she trained all day for the finals, this will be classified as being about a dancer. So we can see that, just having gender bias can lead to inaccuracies in our model. And so reducing bias is important, not just for fairness, but for model accuracy as well. So if we want to employ some techniques to try and reduce this bias, a good idea would be to first measure the bias. So get a measurement of what the gender bias is in the model prior to making any changes. And this gives us kind of a baseline comparator to compare with after we made attempts to reduce it. So we can take any gender neutral phrases, such as they were aggressive, and using the topics male and female, we can measure the difference between similarities to these. So just coming back to the sports example, we can filter the Stanford NLI dataset to sports relevant premises to understand the sports specific gender bias. We can then remove any gendered language from a subset of these premises and replace them with gender neutral terms to then measure the similarity with male or female candidate labels, giving us a bias. So in this case, when we did this with around 250 rows, we got a bias level of about 0.41. But obviously this level is subject to which sentences you have in your measurement dataset. So it's important to stress that this is just a comparator figure and not an actual quantifier of the bias. So how can we reduce gender bias? One way to do it could be to source our own more balanced NLI dataset. So for sport, for example, we could scrape text to do with the WNBA and not just the NBA. And this can be done for any sport, source text about female sports and not just male dominated sports. Another thing we could do is to use gender swapping. So we could duplicate all texts which have genders mentioned and then reverse these genders in the duplicated set. As a result, any stereotypes that could have been in the original dataset will be reversed, and hopefully, as the model is trained, it will learn the opposite and try and counter out this bias. And then another thing we can try combined with the gender swapping would be to include a measure of gender difference in the loss function. So the loss function tries to measure the difference between your predicted probabilities and the actual class probabilities. So we can also add to this a measure of gender difference. Then finally, once you've employed your techniques to try and reduce bias, we can go back to our separate bias measurement dataset to see if gender bias has gone down. So just explaining the loss function a little bit more, and apologies if this is too mathsy or if this is not mathsy enough for some people, but basically what the loss function tries to do is measure the difference between the actual probability and the predicted probability. So why can't we add another term which then measures the difference between the male predicted probability and the female predicted probability, and experiment with different weights in this term? And this is what we're trying to experiment with at Digitas. So some other techniques which aren't specific to ZeroShot, instead of gender swapping, we could have trained a classifier or used a human loop to remove the bias samples in our training data beforehand. However, this wouldn't reverse any bias that was learned at the BERT or BART training stage. It would only prevent further biases from being learned in the NLI stage, whereas gender swapping aims to try and reverse those misconceptions and biases. Another thing that could be done, and another thing we haven't mentioned, is the embedding approach to ZeroShot. So we've talked about using natural language inference for ZeroShot. However, there's another way to employ ZeroShot is using embedding-based models. So let's say we had an embedding model like SentenceBERT, which essentially can map any sentence into an n-dimensional vector space. And then we can use these mappings to figure out the difference between, the distance between two different sentences in the vector space using cosine similarity. And so in effect, we can find the similarity between any sentence or text and any topic. And this is in essence ZeroShot. So one problem with this is that these embedding models also learn biased embeddings. So let's, for now, just pretend that instead of an n-dimensional vector space, it's two-dimensional. And let's say, he is mapped here and she is mapped here. So if we look at the line that's directly in between he and she, we can see there are words which are skewed closer towards she and words which are skewed closer towards he. Now, there are some genuine words which should have a gender association, like queen, fiance, brother, and nephew. They have gender associated to them, and they rightly so should be closer to she versus he. However, if you look at all the words above this horizontal line, these are words which don't have a natural gender association. And so the reason they're closer to he or she is through learned bias in the embedding training. So if you look at words like pageant, salon, closer to she, and words like genius and tactical are closer to he. So what's been proposed in the hard debias algorithm, for instance, is a method that tries to retain all the gender information in these words below the horizontal axis, but get rid of it for all these words which shouldn't have gender bias. And the way that they do that is they first identify the subspace in the n-dimensional space, which encodes this gender information. And then they remove the components in these directions from these words, which shouldn't have a gender component. And so we're left with these words being squished together closer to the middle. So some final thoughts, really, is the methods discussed today to reduce gender bias are by no means a complete solution. Just turning on the news, we see, biased facial recognition algorithms, biased algorithms on social media, which crop, more likely to crop people of color. Just seeing that shows us that we have a long way to go as an industry with respect to bias in machine learning and AI. Other axes of bias, such as racial bias, LGBTQ bias, etc., are even hard to remove in text because of the more difficult task of identifying, what is racial language, for instance. It's not as straightforward. So I guess the purpose of this talk was not to present an ideal solution, but to introduce the idea of measuring bias and to encourage us as data practitioners to include the exploration and reduction of bias as important parts of our daily working practices. So hopefully you'll all agree that this is vital, both for fairness and equality, but also for the accuracy and integrity of the models themselves. Thank you for listening. And before I hand back to Leila, I just want to mention that if anyone wants to learn more about ZeroShot, Param, who's the lead data scientist in our team, has written a really great blog post about the theory about ZeroShot. So I think I'll just post this in the chat for anyone that's interested. Well, thanks for listening. And yeah, I'll hand back to Leila now.
Great, thanks so much, Divya. It was really interesting. So we're going to open this up for Q&A now. You will see a Q&A icon in your Zoom. And if you post in there, I'll be able to see it and pose them to Divya to answer. But I guess I'll just kick off with quite a big, broad question for you, Divya. How would you approach reducing bias for other things? So let's say, for example, race in this instance.
Sure. So I guess we kind of touched on this in the talk, but things like race and racist language in text is a lot harder to identify than gender. It's not simply, a pronoun or a name. It could be more subtle, and there could be, connotations which imply race that aren't necessarily direct or easy to identify. So I guess one thing you could do is maybe train a separate classifier to identify racist language. And then we can use this before doing any training to clean our data set of any racist examples in our NLI dataset. Or gender swapping, when we swap the genders in the training dataset, we could also potentially swap names which denote a race. So that could maybe work for race as well.
Great, thank you. So one question I'll ask, and this is also quite a big meaty one as well. What do you think the hardest thing about reducing bias in NLP actually is, if you could name one thing?
Yeah, so I guess I'd probably say two things. One is, the fine line between language that is racist or sexist and language that should be, have a gender association or racial or cultural association. So take, India should be associated with Hinduism, but, it shouldn't be associated with the racial stereotypes. So how do you draw that line, and how do you, pick it out like that? Which is kind of addressed in the embedding approach, but it's more difficult for when you're doing NLI. But, as I said, maybe we should train a separate model which does identify what is racist, what is sexist. And then I guess the other thing is, finding data sets which aren't biased or which are, balanced, or finding data in general is difficult. So yeah, I'd say those.
Yeah, completely. So I've got a question here, but I'm going to add to it because I think that there's a few issues at play. So the question is gender bias also occurring due to English not having identification for kind of male and female? So English is a gender neutral language when you think about English versus kind of languages like French or Spanish, which are quite gendered. And then there are other languages that are completely free of gender, so Hungarian. And there was an example that came out recently where someone on Google Translate entered a kind of paragraph that was Hungarian, and it converted it to English, and it assigned gender to all of the different sentences. So do you think that in English, in the English language versus, say, other languages, it's a harder problem to solve, it's an easier problem to solve? Are there differences to how you might approach it when you're thinking about other languages that are purely gendered and much more explicit?
Yeah, So I think in a language like French or Spanish, which has gender pronouns for words, it would actually be more difficult a problem to solve. And then we see that in the, the variations of like ZeroShot, for instance, that were meant for other languages. There's even more bias because the terms that may not even have learned a bias association in the training already have this, gender associated to them. So I think it would make it more difficult, but at the same time, a language like Hungarian, which is neutral in its language, may not be neutral in the way that the language is used, so that there still would be a problem there, probably.
This is, I almost think, somewhat of an ethical question. So I don't know that you'll have a specific hard and fast answer. So the question is around when you're trying to reduce issues of bias, what is the impact on accuracy of these models? And have you found that there has been an impact? And if so, do you think that this is something, and this is me adding lib here, do you think that this is something that, we should just kind of build in because that will make the models, I guess, more fair for society, or not? Again, don't know that you'll have a hard and fast answer to this.
Sure. Yeah, so I guess my answer to this is, look, if your accuracy is good for a majority, but really bad for a minority, it's not accurate, right? It doesn't work for everyone. So we've got a case, I think there's like a melanoma classification app that recently has been used by the NHS or something like that. And it's really bad at classifying melanoma for people of color. So is that an accurate model? No, because it doesn't work for everybody. So if you're willing to sacrifice a little bit of accuracy from like 95 to 90% in order to make the algorithm work for everybody, then you actually have a valid algorithm rather than something that only works for a subset of people.
And then a question for you just for the future. Do you think that we're ever going to get to a point where we don't have these biases in our AI and our machine learning models?
So I think yes, and I think yes because we have to, right? So like we have these AI and machine learning algorithms that have been deployed and have been public facing, things like, I'm not going to mention any names, but like social media algorithms and things like that, which are completely biased, and it's in the news, and people are now calling for, I was on Instagram the other day and I saw a post about, saying we need to ban facial recognition algorithms because they're racist, and they are racist, but we don't need to ban them. We need to make them more fair. And, that can be done by carefully curating the data sets we use, making them more balanced, and we can make AI and machine learning become a way to kind of reduce the biases that exist in society rather than exaggerate them, because otherwise, people are just going to say, we're not going to use AI and machine learning because it's biased, and rightly so. So we have to, and we can.
And do you think that the responsibility lies just with practitioners, or do you think that there's certain things that we as practitioners can ask of our companies and businesses that we buy from? I'd just love to hear your thoughts on who else should be involved and potentially how.
Yeah, so I think the onus should be mostly on the practitioners because they're the ones who understand the data and how the bias comes in and how to reduce it. But I think there needs to be like clearer government guidelines as to what standards should there be for an AI model in terms of equality before we start using it to detect like cancer, or start using it in America in the police facial recognition algorithms, which are racist, that shouldn't be allowed. So I think a bit of both, of government and then the data practitioners.
Great. And then I'm just reading this as I go because they're coming in at the moment. So a lot of natural language processing models, actually, this is a good one, developed by big tech, which you kind of just touched on. And these companies kind of are making a lot of hires and getting people to be kind of diverse and things like that. And so how much of these biases do you think need to be kind of taken on by, I guess, the big organizations that are delivering out a lot of these NLP models for people to build off of and explore?
Yeah, I mean, I think that they need to, because, you know, they're kind of the pioneers in this space, right? They have the big computing power, they have the resource and the money to hire, you know, not the best people, but sure, like they can if they want to. And they've got, you know, they often are the pioneers of new models, new architectures and things like that. And not only that, but their models impact more people. So, you know, Google algorithms and things like that. And I think they're already starting to do it. So there's a lot of, you know, research going on. I know at Google, they're doing quite a bit about reducing bias in machine learning and AI, because I think I attended a talk by someone at Google. But, you know, it needs to be quicker. It needs to catch up with, you know, what we want from an algorithm, rather than, you know, releasing algorithms into the public that are already like very clearly racist or sexist or homophobic. You know, that's not acceptable.
And then I think, I guess one thing I'd like to, touch on is, do you think that, and this is paraphrasing a few people's questions here around, does the bias that we're seeing in these models just reflect the bias of society? And to some extent it should. Do you think that AI and machine learning and us as data practitioners actually have the ability to make the world a better place and change the world? And do you think we should? Is that something that we should take on as practitioners?
Yeah, completely. So, you know, the AI and machine learning, they are just taking the biases that exist in society and learning them, because that's what they're trained to do, right? But if we have the power to tweak our data sets or tweak our training process, is to, you know, make algorithms which don't contain the biases which are reflected in society, then we can push towards a positive change rather than making, you know, a negative impact through the algorithms. And yeah, definitely, I think we should, if we can do.
Amazing. So I think that might be it for today with the questions. I think in the chat, Data Science Festival has put Divya's details and my details on LinkedIn. And I think there are a few specific questions that feel free to reach out and we can answer if you didn't feel we got to them. Thank you so much, Divya, and attendees, please feel free to thank her again in the chat. It was really informative, and I think we all can do more and kind of take our skill set to change the future. So thank you again.
Perfect. Thanks, everyone. Thanks for coming.